All right, so we're going back to our fixture. It really doesn't matter on the stock for this. What we're doing is we're actually drilling into a plate that's not modeled here, but we want to pick up on the locations of this model. What we're doing is we're making holes that we can put bolts through. They're threaded in our subplate below this. Now, technically, you probably only need 3 of the holes. I'm going to go ahead and do all 4. In case something gets fouled in the fixture, you have more than one option of where to place bolts. Okay, so we got 1, 2, 3, 4 locations. In reality, you'd probably only put 3 bolts in unless you got a problem, and then maybe one of them, you could plug off. Okay, so but 3 points make a plane and would force the part flat. The 4th location again would be just an optional location. Okay, to do this, we're gonna drill and tap the same 632 size that we're using for this hole pattern. So what we can do is we can take and highlight the 3 routines that we're using to make those holes, and do a right click copy and then a right click paste, and we've copied the 3 routines we need to make the threaded hole. So we've got our spotting drill, we have our tap drill, and then we've got our tap. This is going to take a little bit of visualization. We're going to pick up on the holes and we're cutting into basically what's going to look like air. So we're going to use the geometry of the bottom of the part. So that's where, if the part wasn't on the table, that's where the cut would be in the fixture that's sitting below it. So I'm going to go edit. Okay, and we're going to leave the first set of parameters alone. Actually, I'm going to bump the RPM up. I'm going to assume my fixture plate's aluminum. And we can probably go faster, so 20 inches a minute. On all of these. Okay, we're going to go to the faces and we're going to change faces. And we're going to look at the bottom of the part and we're going to grab the first chamfer we see from the back side that's the clearance hole. And we're going to select everything that's the same diameter. And on the next tab, we're going to go from, I guess it's from model bottom. And we're going from the hole bottom. Yeah, it's fine for that diameter because that's what we did on our threaded hole. So we'll end up with a little chamfer at the top that's the same size as we put in the steel plate. But again, this is going to be, the part is actually not on the machine at the time we're cutting this, and we're cutting locations in aluminum plate that it sits on top of. Okay, this is a quick way to cheat it. Okay, we're going to keep that at parameter at default, and we're going to select OK. Alright, so we're just going down a little bit. Now we're going to go to drill, and we're doing the drilling for the screws that are going to go through. Okay, so we're going to go edit, and we're going to go bump the RPM up to 4,000. Again, 20 inches a minute, because we're cutting aluminum in the subplate. And we can delete all these faces. And we're going to select the same face we just did. And we're going to select same diameter. We don't need to auto merge. We're going to go to heights. And we're going to do the same thing. We're going to go from model bottom and also from model bottom for the depth. But we're going to go a half inch. So negative half inch, 156 thousandths to make sure our drill goes deep enough that our tap that follows has room. Okay, and we're going to leave the others at default. Actually, yeah. Alright, now we're going to go to our tap. We're going to do the same exact thing. Okay, we're going to go up to 500 RPM because it is aluminum. Okay, and we're going to go to our faces and we're going to delete all the ones we selected. We don't need auto merge selected since we're just doing individual faces. Okay, and we select our first hole. Our heights. We're going from model bottom. And we're going from either hole or model bottom. I'm going to say model bottom just to be safe. And again, we're going to go negative 93 thousandths to make sure from the bottom we want to go negative, and we want to add a ½ inch to this. So it's going a little bit deeper to make sure we have a fully formed thread. Now the scale of this part's really small, so this looks a lot deeper than it really is. Okay, we're going to accept that. Alright, so now we have our fixture made. Alright, so you finished the first milling part in the milling segment. Again, you need to submit 4 NC codes and 4 setup sheets. Go ahead and have the fixture displayed. In the fixture, go ahead and have your model stock displayed. If we were doing this thoroughly and we wanted to document all our fixtures, we would do a separate model for the fixture and a drawing so that fixture could be recreated. But this is kind of a quick and dirty way to show how to do a multi-setup part where you have to do clamp avoidance, or you have to have the operator intervene with the part. Okay, that's it, and we'll catch you on the next one.